Yeah, thank you so much for joining this lesson. We're going to discuss indices and logarithms. Remember, these lessons are used to prepare people for the Kenya Junior Secondary Evaluation. And also, it's going to be very important for those who are waiting for the Kcse. The topic that we're going to discuss today is also a strand in grade 9, and therefore I'm going to accommodate both categories of students. So whether you are preparing for Kcse or whether you are preparing for the Kenya Junior Evaluation, then you are in the right platform for indices and logarithms. Remember, as usual, subscribe. Remember to share. Remember to comment. Yeah, we can know where you are watching us from. Let's know whether you are getting us clear as we begin indices and logarithms. So we'll be doing the laws of indices in particular in this case, and we begin by indices themselves. So indices is simply the plural of an index. An index. I'm going to be making use of the board, so I'll write a lot. Make sure you are following what I'm writing. Don't just stick to what has been displayed. Watch what I'm writing about. An index is simply the power into which a certain number has been raised. So when you raise a certain number to a given power, then that particular power is what we are calling the index. The plural of index is indices. When we say, for example, 3 power 4, in this particular case, I can say that 4 is the index, because this is the power we are raising, is the power to which a given number has been raised, and the so raised number is called a base. That is now what you're supposed to understand as we begin interacting with indices and logarithms. Check, for example, 2 raised to power 5 means it itself 5 times. So 2 times 2 times 2 times 2 times 2. That is the meaning of 2 power 5. So in such a case, 5 is called the power and 2 is the base. 2 is the base. Look at this. 10 or 10 squared. If we are raising 10 to power 2, then the base. So that is it. Now, tonight. Yeah, you comment. You can remember to subscribe, as I also cite examples. So I'll be giving a law plus a few examples, and I hope we will flow together. I'm checking something with my connection. Can give me a few minutes. I'm working on the display, so you can just give them. I'm setting up everything right now. Yeah, check. The laws of indices. Okay, somebody is calling them rules, but we can call it the first law, which is called the zero index. The zero index. Now, the zero index states that any number except zero itself, whose index is zero, is always equal to 1. In other words, any number raised to base 0 is equivalent to 1. We can put it number A raised to power 0 is usually equivalent, basically the law. When you are given 5 raised to 0, the answer is simply 1. When you are given a number, no matter how big it is, then we raise it to power 0, the answer is going to be 1. So no matter the base, as long as you are raising it to power 0, the answer becomes 1. So we proceed. That is the first law. So anytime you see a number which has been put to base, which has been raised to power 0, then the equivalence is going to be 1. Rule number 2. To multiply an expression with the same base, copy the base and add the indices. In simple law of indices, this one states that if you are given a certain number, say A, raised to M, then this number is being multiplied because the base is the same. Then the answer is going to be A power the sum. We know how we arrive at this conclusion. In this manner, assume you are given 2 power 3, then this one is being multiplied by 2 power 4. Then we learn together. So as you keep planning, you can also share the link with your friends. You can also invite other people to the live broadcast. I'm still demonstrating the first law. I'm still working on the first law. I'm still working on the first law, indices. And I hope you can get what we are saying. Yeah. So this is where we are. Yeah. This is where we are, whereby we are having a 2 power 3 at this point, then 2 power 4, at that point. Yes. So you look and you discover that at the end of the day, we are having 2. Now, when you compare what we are having at the end of the day after multiplication, you discover that it is equivalent to, if we have gone to the first expression and we just put it down as 2, then raised to 3 plus, we would still have gotten power 7. So because it is evidenced that when the base is the same and we are multiplying, then we can do it faster by just picking the base and adding up the indices as we agreed up there. So when you are told to work out, for example, 5 power 2 multiplied by 5 power 3, then simply it will be 5 power 5, which is equivalent to 3,125. So that is how you'll be handling a logarithm. That is how you'll be handling an index equation or an index question, whereby you are evaluating and what you have is similar bases with different powers. There is rule number 3, which is the division law of indices. The division law of indices. Now, on the division law of indices, we usually argue that when you are given the same bases but having different powers, take A power m. This time round, we are dividing by A power n. Then this will be solved easier by picking the base. Then you just subtract the indices. Look at this illustration. You are told 5 power 6 divided by 5 power 2. This will easier be written. You can just write 5 power 6, which means 5 times itself 6 times. 5 times 5 times 5 times 5 times 5. Yeah, I believe those are 6 times now. Then this one is supposed to be divided by. This one is supposed to be divided by 5 power 2, which is 5 times 5, just 2 times. Looking at this now, you discover that from the denominator and the numerator, we will have a 5 simplifying with a 5, 5 simplifying with 5. Then what remains is 5 times 5 times 5 times 5, 4 times. So this is going to be equivalent to 5 raised to the power of 4. An indication that when the power was 6 and we are dividing with the same base and the power is 2, then we would have simply taken the base, which is 5, and we just subtract the indices, the way I have concluded at this particular point. Yeah. So that is how we handle division of indices when the bases are the same. As we continue looking at examples, look at this. You are encouraged to subscribe to this platform, to share the link so that you may invite more friends. Yeah. 9 power 5 divided by 9 power 2. So it will simply be 9 raised to the power of, we have 5 and 5 minus 2, which is 9 power 3. And that simply becomes the answer. Though you can still compute the value of 9 power 3, 9 cubed, that is, it will be 729. 729. As we continue learning, I'm here to remind you of our programs, whereby you can just go to your M-Pesa and purchase airtime of any amount. Just go to the M-Pesa. The pay bill number is 737356. The account number is the phone number that you're purchasing airtime for. Then you enter the amount you'd like to spend and you continue with the transaction. Your airtime is going to reflect instantly. the airtime is going to reflect instantly. So as we continue preparing, you can use this facility and you can also invite your friends to the same. Thank you. Look at this. We are told that in rule number 4, to raise an expression to the nth, this one is nth, should be written this way, to the nth index, copy the base and multiply the indices. In simpler terms, I am supposed to clarify this one, and I tell you that it is called the product law of indices. The product law of indices this one, we usually say that given a power m, then everything now is raised to power n. Then this would be easier solved by saying a raised to the product of m and n. You just multiply the two powers. So m, n, you just take the product. And now you simplify and get your final answer. Look at this example. 2 power 3, then raised to power 2. You know, if I start by working what is inside the brackets, then I'm going to have 2 times 2 times 2. Then I am supposed to square. Remember, I'm supposed to square. Therefore, to square means I multiply whatever is in the brackets by itself. And to multiply by itself means, because I'm having a, 2 times 2 is 4. Times 2, we get 8. So 8 squared, which is 64. That being the answer. The argument here is, instead of taking 2 power 3, then we later square, we can just take 2 multiplied by the power of 3 power 2, which is 6. And when you check out this one, you discover that the answer is still 64. Actually, this can be demonstrated at this point. When we have 2 power 2 power 2 times 2 times 2 3 times, then we are squaring. Then it means to square, we have to multiply the same thing by itself. This way, 2 times 2 times 2. Then we get the answer. At the end of the day, we will find ourselves at 64, which is equivalent to 2 power 6. And power 6 means the power of 3 and the power of 2 have been multiplied, meaning that it is easier to just get the product of the powers rather than opening up using long methods and all that. Go quickly to the answer. 5 power 3, everything squared. This means instead of raising 5 to power 3, then we begin squaring the product of the powers. And this is going to be 5 raised to power 6. Yeah, 5 raised to power 6. Look at questions like this one, whereby we are told to solve for x. These are simple equations which are involving the few laws of indices that we have covered. Therefore, we'll be talking about 4 power x. 4 power x plus 1 equals to 32. Now this calls for expressing a number in terms of a base and a given power. And this is going to be on the left hand side. We make 4 raised to power x plus 1. We can make it 2 squared. Yeah. So now I think we can continue. Thank you. Thank you for your... Yeah, things are now okay. Sorry for the interruption. Yeah. So now I think we can continue. So on this side, we were talking of the product law, which will leave us having 2 power to x plus 2. This is equivalent to 2 power 5, meaning that because the bases are now the same, we can just equate the indices and talk about 2x plus 2, which is equal to 5, because the other power is 5. Then now we'll be talking of 2x equivalent to 3. Then x is equal to 3 out of 2, which is 1.5, or simply 1.5. Yeah, 1.5. So that becomes the final answer and our value of x. Look at another question here. Look at another question whereby we are being told to find the value of x, which satisfies the equation as 16 raised to x squared. This is equivalent to 8 raised to 4x minus 3. Let us look at this now. We're going to have 16 being put to base 2, and this will be 2 power 4. Then there is already an x, which is squared, equivalent to 8 can also be put to base 2, which is going to be 2 power 3, and there is already 4x minus 3. So now we can deal with it, whereby this becomes 2 power 4x squared, and on the other side we shall have 2 power 12x minus 9. Then at this point now we can just equate the powers. So what we're having is a quadratic equation. What we are having is a quadratic equation. And that is why I'm saying this particular setting, then we solve it on the school level. What we are having is a quadratic equation. That is why I'm saying this particular setting, then we solve it on the school level. So we can talk of a multiplied by c. Let me change my ink. 6 and negative 6. This is going to be 4x squared minus 6x minus 6x again plus 9 equivalent to 0. So in the first two, let's factor out 2x, I think. So 2x is common. We remain with 2x minus 3. Then minus 3, we remain again with 2x plus the value of 3. This is equivalent to 0. From the brackets, we are having 2x minus 3. And outside the brackets, we are also having 2x minus 3. This is generally equal to 0. If this is equal to 0, we can see that the fact we are dealing with what we call a perfect square, whereby after solving answer. Yeah. So 2x, and so 2x is equivalent to positive 3. This implies that 2x is equal. Yeah. So we'll be checking more examples just as we continue. But remember to subscribe, remember to share, remember to invite a friend. Yeah, remember to be a subscribed member of Shifting Grades Online School. That way you're going to be a very lucky student. Yeah, reminding you of our facilities like the airtime subscription, whereby you just need to go to your M-Pesa, the Lipa na M-Pesa option. Then with that, you can just access any amount from our pay bill, which is a 73.56. So please just go to that pay bill and purchase the amount of airtime that you would like to spend, or as much as you can spend. Remember also to leave a comment. Make sure we know that you're getting us well and you are cooperating in the lesson. So solve the equations. There are several. There are many. They are numerous. They are good for your exercise. You can even take a screenshot of all the work which is displayed here so that later you may work out these questions. But for now, allow me just to check the first one. Yeah. Then after that, now I'll be proceeding to another law whereby we will also do more examples. Then I'll be allowing you now later to check more examples and to get used to these questions. In the first question here, 3 power 2x, everything has been raised to power 3. So we are being directed to the product law of indices, which says at that point, we just need to write 3, then power the product of 2x and 3, which is 6x. This is equivalent to 3. Now the product law, the multiplication law, sorry, the first one that we covered, the multiplication law, which says when the bases are the same, we just add the powers. So 4 and 8 added will give us 12. And now that the bases are the same, you can equate both sides and talk of 6x is equivalent to 12, and the value of x becomes 2 when you divide through. I'm finding more space to try with you another example here. Look at part D. Just look at this question. Question D. The question is telling us that 4 raised to the power of 5x divided by 2 raised to the power of 3x, then everything has been squared. This is equivalent to 256. Equivalent to 256. So from the right hand side, we can begin putting every composite to the least base possible. The least base according to this equation is base 2. Therefore, 4 to base 2 and 256 also to base 2. So 4 becomes 2 squared. So 2 squared, and there is already a power of 5x. This is divided by 2 power 3x, then it has been squared. So that becomes 6x, equivalent to 256 can be written as 2 power 8. Yeah, 2 power 8. So 2 to the power of 8 is equivalent to 256. So now that we are having the same base, we can apply powers more. We can apply laws of indices or laws of powers. Check here. This is 2 power 10x because we have to multiply here, the product law, divided by 2 power 6x equivalent to 2 power 8. But look at the left hand side whereby the bases are just the same. So we have to take 2 and we subtract the powers. I'm having 10x minus 6x, giving us 4x, equivalent to 2 power 8. Therefore, I can now equate the powers and talk about 4x being equivalent to 8. So the value of x becoming 2. Yeah, the value of x becomes 2. And many other base. Now we are having the negative indices or negative law of indices. Allow me check on the connection as we just continue. The negative law of indices. Yeah. Yeah, we proceed with the negative law of indices. Sometimes a number is going to be raised to a negative power. A number will be put into a negative power. Look at this. When dealing with a negative power, you simply change the power to positive by changing it into a fraction with 1 as the numerator. Okay, I will not buy this idea because not all the times that the number will be an integer. Some other times we'll be applying such laws on fractions. And so we can simply say that the power becomes positive by taking the reciprocal of the base, by taking the reciprocal of the base, by simply taking the reciprocal of the base. That is what you're supposed to understand. Just take the reciprocal of the base, the power becomes positive. So given number A raised to an index which is negative, then we solve this by taking the reciprocal of A, then the power becomes positive. Yeah, the power becomes positive. So when I'm talking of 2 power negative 2, this one I mean, it's going to be 2 power negative 2 means I'm supposed to take 1 over 2, then I raise everything now to 2. And this is going to be a quarter. That is going to be a quarter. So a quarter becomes the final answer in such a case. We have another example here. Whereby we are being told that 2 power 3 is multiplied by 2 power negative 3. Or, we can solve this question in 2 different ways. We can first of all follow what they are talking about, or we take it to a higher level where I'm going to show you. We can say that 2 power 3 multiplied by 2 power negative 3 means 2 raised to the power of 3 minus or plus negative 3. So we are adding a negative 3, and adding a negative just remains negative. Therefore, minus negative 3, and this becomes 2 power 0. And anything power 0 is 1, according to what we stated first, the zero index. The zero index. But again, we can say, this alternatively now, we can just say that 2 power 3 multiplied by 2 power negative 3, this one would imply 2 power 3, then we multiply by 1 out of 2, but now everything becomes power 3. So this is going to be, we take 2 power 3, which is 8, or just 2 power 3 divided by to power 3. Now, when we divide two equal values, then they have to simplify to a value equivalent to 1. So 2 power 3 divided by 2 power 3 simply becomes 1. Yes, so that is it. There can be more questions of the same, but now allow me introduce to you the fractional law of indices. The fractional law of indices says that you can be given a number which has been raised to a power which is a fraction. For example, or generally, if you're given a raised to m out of n, then this will be solved by we take the nth root of a, then everything is raised to power 3. Take a simple example of 8. So we usually root and the numerator is a power of the same base, and we begin by the root. So given 2 power m over n, we operate the nth root of a, then now we raise to the m, power. That is how it functions. 8 raised to power 3. Let me use power 2/3. We have to take the third root of 8. Then now everything we square, because we are supposed to take third root power 2. The denominator is the root, the numerator is power. That is it. Therefore, the third root of 8 is 2, and 2 squared gives us 4. That is a very simple answer. Look at this. What you would to take 27 raised to power a third. 27 power a third. Then everything is to power 1. Third root of 27, and you'll be done, because anything power 1 is just itself. 16 raised to 3/4. Another example is 16 raised to 3/4. So 16 raised to 3/4 means we take the fourth root of 16, then now everything has to be cubed. So the fourth root of 16 is 2. The fourth root of 16 is 2, then 2 has to be raised to power 3. And this is going to give us an answer equivalent to 8. Yeah, an answer equivalent to 8. So that is it. That is it. There are some questions here, and there can be questions which are involving indices. Actually, I can let's look at the question at this point. We are told to first find the value of x according to the examination here. 3 plus 3 equals to, this is plus 1, but we are having a 28 on the other side. Therefore, if I'm to take the, and now we have to put 27 to the 2x plus 3 equals to 3 power 3. Now that the bases are the same, we just equate the powers and talk of 2x plus 3 equivalent to 3, so that the value 2x. Let me check something to do with my connection at this point. Yeah, but you can be sure everything is getting well. Remember to subscribe. Remember to share the broadcasts with friends. This is a platform that you can benefit from, regardless of where you physically are. Just need to be subscribed. Anytime we go live, you are going to see our lessons. Apart from the live broadcast lessons, learn also be updated that we have we have more than 1,000 lessons already uploaded. You see the answer is now 0. So you can always reach out to the channel Shifting Grades Online School, and you find as many questions as you need. In upper 11, we're going to solve, we're just evaluating, but without a mathematical table and a calculator. Remember our services on airtime, we just go to your M-Pesa, Lipa na M-Pesa, then the pay bill number is already displayed now, 737356. The account number, the phone number that you'd like to purchase airtime for. Then after that, now you can complete the transaction and you receive the airtime of any amount from our facilities. Utilize and invite your friends. Thank you so much. Without using mathematical tables, calculators, evaluate. 27 two-thirds. You know, this one is a fractional law. So it means we will talk about 27, but we take the third root of 27, then everything now has to be squared. And we multiply by, now looking at the other bracket, it's having 81 over 16, but this one has been raised to negative 3/4, which means we have to take reciprocal 16 over 81, then now the power becomes positive 3/4. So the third root of 27 is 3. 3 squared becomes 9. Multiplied by, we have to take now the fourth root of 16 and 81. Then now the answer after that, we cube it. So this is going to be 9 multiplied by, the fourth root of 16 is 2. The fourth root of 81 is 3. So we have 3 out of 2 cubed. 3 over 2 cubed means 27 out of 8. 3, sorry, this is 2 out of 3 because fourth root of 16 is 2. Let me even give it at that stage. This is now what we are cubing. So I'll talk of 9 times 2 power 3, 8 out of 27. So this is going to be by 9 1 and by 9 3. So 8 out of 3, which is equivalent to a number as an improper fraction. That will be mathematical immaturity. For us to finish, we have to say this is equivalent to 2 and 2 out of 3. Yeah, 2 and 2 out of 3. Yeah, we can check it. Question here, just as yeah. Let's check. "27 out of 8, it means that these two numbers can be put to a common power. For example, 27 is 3 power 27 is 3 power 2. 27 is 3 power 3. 8 is 2 power 3. So you put to a base, even if the base is not the same, then we can break them to equal powers, meaning we can write 27 over 8 as 3 over 2 raised to power 3, because that will be 27 out of 8. Then now there is an existing power of x plus 7. This is equivalent to, looking at the right hand side, we have a fraction, the power is negative, instead of negative now, positive 3x. At that point, we can also examine 2 and 9 and discover that 9 is the equivalence of 3 squared, and 4 is the equivalent of 2, also squared. Simply express 9 over 4 as 3 over 2, but everything squared. So 3 out of 2 raised to a power of 3x plus 21 equals to 3 over 2, everything squared. So we are squaring, and there is already 3x. So that is 6x. 7. So that is how we work out such questions. That's how we work out such questions. Remember we have our consultation line S0704E66. You can reach out through that number for any consultations. Thank you so much for following. Subscribe and share this broadcast.